I can tell you how good it feels to be back on a big stage, right? So the last time I was on a big stage, that was like February last year, actually. So it was I think it was the opening keynote to JS World or something. And don't worry, I'm not going to joke about different programming languages. I learned not to do that. So this is a personal talk. It's actually a brand new talk. I haven't done it before. So if I fail in my timing, if it's boring or whatever, it could be because you're my tryout audience, basically. So let me start by saying this is my journey, right? So when I was asked to do the keynote, I was like, what can I tell that is not already being told? Well, my personal story, of course. I can tell you about, yes, you need to do OO, you need to do design patterns, you need to do solid, you need to do yada, 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 and unit test, of course. But I want to show you a bit about what I learned along the almost 40 years that I've been writing code. I've been writing code since, I think, 1981. So given this is a Java audience, most of you were born yet, and if you do this in a JavaScript audience, there's like, what? Did they have computers back then? Well, yeah, my Commodore 64. It still works, by the way. So this is my personal journey. And because it's a journey, I'm going to talk a little bit about travel, and I'll talk a little bit about how I write code, basically. It's not meant to say you have to write code like this. It's meant to say I write code like this, and if you take something away from it, please do. So I love to travel, and I love to write code. Those are basically my hobbies, I would say. Now, I find this nice word on the internet saying you could be a travelist, which is slightly different than being a traveler. So I looked up what the definition of that was, and the definition of that was, well, it's a bit long, so I'll put a red thing around it, and it says, those who wander to fully experience a new locale, and the culture, the people, the approaches to the everyday common task we all endure, to learn to be inspired, to deepen the soul, and enlighten the spirit and refreshen the mind. Wow, that's a mouthful, right? It does sound a bit of like how I experience travel. It's also how I experience writing code, usually, except for the big difference is that coding is 90% frustration, as we all know, right? So it's, oh man, I can get so frustrated when something doesn't work. I actually can stay up on like 4 in the morning and then I'm like, what? It's so dark, everybody's gone to bed and I'm still writing code. So I sort of rephrased it and like, those who code, if you want to be a codist, those who code to fully experience a new locale, an LNL, the culture, the people, the approaches to the everyday common tasks, or call it stories, whatever you want, we all endure to learn to be inspired, to deepen the soul, enlighten the spirit, and refreshen the mind. Now, isn't that cool, right? That is what I sort of want to be when I grow up. Yes, I'm old, I know. But anyway, so the great programmer Aristotle said, well, before the things we have to learn, before we can do them, we learn by doing them. And this is typically it, right? Malcolm Gladwell says you need at least 10,000 hours of practice to become really, really good at something. Like the Beatles, they practiced forever in the basements in Hamburg. And like Bill Gates, for instance, well, okay, not a good example here, but Bill Gates practiced programming since he could read, basically, right? This is the point of you need to do it continuously and slowly get better. It's a bit like the old adagio shuhari, right? You probably know this, right? First, you need to learn the rules, right? You need to learn from somebody who's done it before. I'm going to point it here. Well, it's look a bit drunk though, but so you need to learn the rules, and once you've learned the rules and you blindly can actually apply them, you slowly start to detach from them. And in the end, you sort of transcend, which means you can find your own thing outside of the rules. Like the Scrum community, I have to bash on Scrum a bit, sorry. So that's okay, right? You all don't like Scrum either, right? No. So basically, a lot of the people stick into the shoe stage, right? It's like, yes, these are my rules. This is the Scrum guide. I have to have sprints. I have to have retrospectives. I have to have stand-ups. I have to have user stories, which are not in the Scrum guide anyway. But and they stick with it. And they're like, no, you have to have sprints. And I'm like, I don't like sprints. I'm beyond that. I do continuous delivery, right? So why would I do sprints for? Yes, because in the Scrum guide. Yes, so what? Well, that's the whole point, right? You need to transcend from it. And it's the same with coding. Once you learn something new, the next step is, where do you take it? Well, how do you make it your own? And how do you transcend from the rules you've learned? Because otherwise, we would all be doing the same thing, right? We would all be writing our code in the same way. And the good thing about coding is that it's that intuitive feeling that you can have when you write the code and when you make it work. That is such a beautiful moment, right? And we all recognize that. So for me, it has become much more, well, let's say Zen-like. I'm going to move away from all this East Asian shit, but I have to get through it first, right? So what does Zen basically mean? Well, Zen says Zen is a state of calm attentiveness in which one's attention are guided by intuition rather than by conscious effort, right? And a nice example is the Zen of gardening. You become one with the plants, lost in the rhythm in the tasks at hand. Cool, right? But for me, it's the intuition part that is most important, is I code by intuition, basically. I don't apply rules. I don't check for which design patterns to use or not to use, or how to set up my functions. And it has become sort of an intuitive feeling about what I like and what I appreciate about what my code looks like, right? So I came to the Zen of Programming saying, you become one with the code, lost in the rhythm of the tasks at hand. Cool, right? Now, let's do something, right? Okay, so what about learning? How do you learn then, right? There's a great analogy in a book by Gerald Weinberg. Gerald Weinberg has died a long time ago, but he wrote a book called Becoming a Technical Leader. In this book, he describes very nicely how learning proceeds. And he says, well, I tried to learn to play pinball. Very different example, right? You say, what's to learn about pinball? And his original assumption was that it sort of progresses over time. It's a linear function, right? You can say, oh, it gets better slowly and slowly and slowly and slowly. And then he started measuring his scores at the local pinball machine in the local bar in the town he lived in. And he said, well, it's not like that at all. My scores slightly go up until I get to this point where they all of a sudden get a lot better. And then progresses like that again, and then it felt like that. And he tried to identify what made this work. So he jotted down all his scores he had on the games he played on the same machine, and he realized that right before there was this strong incline in his scores, he actually had his scores go down a bit. And he was wondering why that was. And the reason he found for it is he said, every time I slowly progress, at some point in time, I have, let's call it an epiphany. I have this idea about how I can get better, how I can make it better, maybe how I can write my code better, and I have to try it out. It fails at first. This is experimentation, right? It fails at first until you get it. And the example he gave is multi-ball. Okay, have you played pinball before? Do people still do that? I love to. And so what happens with multi-ball is you get multiple balls in play at some point in time. I never understand why, but at some point in time, all the machines I play, they have like 5 balls in play. Like, what do I do? What do I? That's the question, right? And he thought, what if I keep my eye on this single ball so that I don't lose them all at the same time? That happened to me quite a lot, right? You play these 5 balls and you're like, and all of a sudden, buff, they're all gone. Right? And he said, well, I keep my eye on one, and that one I keep in play, so I can continue to play. And he tried that out for a bit, and he got better. And his score increased like, phew. So he had this epiphany, and with this epiphany, you learn. This is how it works. You get an idea, you try it out, you fail at first, and at some point in time, you realize it starts to work, and then you get a lot better. It's exactly the same with coding, I found. So Gerald Weinberg says, well, we must learn from any place we can and any way we can. And by the way, I think that doesn't only include learning. It's not just more and more and more and more. You also have to let go of stuff. So it's basically learning and unlearning at the same time. Now, I found this nice graph on LinkedIn earlier this week, which is pretty cool. And actually, I thought it was surprisingly correct for what I have done in the 40 years of programming. I started really simple because I didn't know shit. By the way, I learned to write code from a book. A book is a big pile of paper and they put letters in it. When I learned to write code, there was no internet, right? You literally had to learn from a book. The book was all you had. It was a big black book, Pascal on it, so I learned to write Pascal, right? Really cool. And I got better at it. And eventually I got to a point that I started doing things that were not in the book. Weird, right? And then I started learning OO, like in the 80s. And I learned design patterns. I read the book when it came out in '96 or something. And I started adding all of those layers and abstractions and interfaces and all of this stuff you can imagine that you think you need to build a decent application. And in most cases, it probably is. The point was to me is that at some point in time, and I don't remember exactly when, I started letting go of a lot of those ideas. It doesn't always have to be 60 layers of inheritance. I don't always have to use an abstract factory, right? I can do it without. Dependency injection, pretty cool. But I can also write a lot of code without using dependency injection. It still works, right? And so I realized that I was on a quest for simple code. And what simple code is always in the eye of the beholder, right? What could be simple code to me could be rather strange to you, or what could be complex to me could be simple to you. It's all based on context, right? There is no such thing outside of context. What I realized is I will never be there. There is never going to be a point that I said, this is the simplest code that I can ever write. I have thought that for the last 25 years, and every time I was wrong. So no surprise would be that if I write code next year, that my code will be simpler than the code I write now. And there is a good reason to write simple code, right? Because simple code is better. So the question is, where do you go? This is a good point to introduce myself, right? So my name is Sander Hoogendoorn. I'm an independent dad, as I like to call it. I have 3 kids. About 1.5 of them live at home. I'm a speaker and author. I travel a bit. I'm sort of a serial CTO. And I'm a mentor, and I'm basically a lifelong programmer. That is the one point in this, well, except for being a dad, the one point is that I'll never stop doing. Probably until the day I die. I'm currently the CTO at iBoot.com, a well-known e-commerce company. I was born to be a programmer, I'll show you. Listen, I was double object-oriented. It gets worse, by the way, because I live in the Java street. I like to say, oh, I don't want to have an apartment in the Java street. Yeah, sure. So I also do write some open source stuff. This is basically the result from the last 5 years of programming in TypeScript, and we built a framework out of it. If you look at the framework, it reflects quite a bit of the stuff I'm saying, which is, well, no surprise, right? So let me tell you a bunch of stories. The first story is about the wall in the desert. So this is in Wadi Rum in Jordan. And the interesting story about this is a guy called Wim Groenendaal. He used to be my first mentor when I was like 26, 27. I came into his team and he said, Sander, listen, imagine walking in the desert. There's a thick fog. So you don't, fog is a bit hard word to say in English, right? But you can only see about, what, 30 centimeters, maybe 40 centimeters. So you don't see anything right in front of you. Now, imagine that there is a wall in the desert. Well, there could be a wall in the desert. You don't know. It might be there, it might not be. You might run into it, you might not run into it. And you don't know. So what do? Well, you start walking. That's the thing, right? You don't know, so you just start doing it. And that means that because if you don't know exactly what you will run into, all of these managers that come to you with the questions, when is it done? Why are you slower than your neighbor? Why is your velocity slow? How many points can you do per week or per sprint or whatever you do, right? They're all wrong. It doesn't work in software development. They should stop doing this. Like, oh yeah, we need to have a personal velocity. These are actual charts, by the way, from a manager this year. And like, oh, he had a velocity of 14.8. Pretty amazing, right? What did the other dude do? He did like 10.5. He's slow, right? They should kick his ass, I think. So there's a nice quote from the famous US programmer Donald Rumsfeld. He said, well, there are the known knowns, right? There's the things we know. And we also know that there are known unknowns. There's things that we know that we don't know. Those are okay, basically. Where it goes wrong is where you talk about the unknown unknowns, because these are the ones you don't know that you don't know. Right? This is the talk you need to do to your manager. He'd say, listen, dude, Donald Rumsfeld says, and he's a famous Java programmer. He's not, because he doesn't have a beard, right? So, and he'd say, there's the unknowns. That is why we cannot estimate. They'll hate you for it. I do this every day with my manager, by the way. And he said, well, it's basically the latter category that tends to be the difficult ones. Well, no surprise there, right? And then your manager comes, yes, I get all this, and I get all this Agile stuff, and I get all this stuff about you cannot estimate, but when is it done? And they need to stop doing that, because there is no productivity in this. You cannot say the more code we produce, the more productive we are, because code is not the product, right? Code is the cost. Code is the thing that we need to spend time and effort and thus money in to make it work. So we should stop doing this. And I put it on Twitter. I said, well, please stop doing this. We are not building two software, right? It's not like building two cars. This is a very different world. This is the world where the code lives in your head. Now, this is Aarhus in Denmark. It's a nice, small, mid-sized town in Denmark, and they host the JAO conference. I was there in 2003 and, to deliver a talk, and one of the other speakers was this fiercely looking guy. You know who this is? You should. This is Ken Beck. And people are like, what is Ken Beck? Look it up. So, Ken Beck stood on a stage, and I was sitting in the front row, and Ken Beck said, I'm not going to refactor the code yet. And he said, because the code doesn't know yet where it wants to go. And I sat next to Alistair Coburn, and Alistair said to me, his feet just left the ground. And that was such a cool moment, right? And I was like, what does he mean by that? What does he mean? Well, the point is, you don't write code on the keyboard. The code you write is in your head, right? All the time. I'm pretty sure that every one of you in this room, including me, has a piece of code running right now, somewhere in the back of your head. I have that like all the time, basically. It's like I cannot help it. And that is something you have to deal with, right? That is, because it delivers in your head, you have no timeline for it. So it doesn't fit in time boxes. It also doesn't really fit well in 9 to 5. Because our mind doesn't work like that. I get my ideas in the shower, when I'm in the car on my way here. Not always at the keyboard between 9 and 12 or between 1 and 5. It doesn't work like that. Also, this stuff is highly addictive. And because it's highly addictive, it tends to clutter up in your head. It tends to fill your head. I have a lifelong issue with focus, because the code is always there in my head. It takes up a part of my mind, and the other part of my mind I need to spend into my family, my friends, my kids, doing sports, stay healthy, take care of my mom, and stuff like that. I always need to find that balance, and that is not easy, actually. If you have this code running in your head all the time, and well, you look like, what is he talking about? But I assume you know what I mean. So find that balance. And then the way to do that is to always travel light. Now, as I travel quite a bit, well, now for the past 2 years, I have a whole collection of backpacks. Actually, this is my smallest day pack that I bring if I travel with this as well. But so I have a wide collection. Depending on what I'm doing, I take a different backpack. I take a slightly heavier or slightly lighter load that I put in the backpack and I take with me. Again, that is pretty much like programming. The lighter the backpack you can bring, the simpler the code you're going to write. Right? But we're not good at that, because as Neil Ford says, he says, well, developers are drawn to complexity like moths to a flame, often with the same result. Gregor Hope says it worse, by the way. He says, well, basically, excessive complexity is nature's punishment for organizations that are unable to make decisions. And the same goes for developers. And there we are, right? Every developer, well, that's me, right? We all say the same things. We're like, yes, well, we might need this in the future. Eventually, we will need this. What if I make it more generic now so we can benefit from it later? What if we want to replace this database by another at some point in time? You all do this, right? Especially the latter one. Like, yes, but what if we want to replace MariaDB with CloudDB database, whatever, right? What if we want to do that? Who's ever done that, right? We build all this complexity into our code that nobody asks for. And that's the problem, right? And what you need to do is you need to learn about these keywords, about we might, in the future, eventually, later, or what if. All this code that you build in for these reasons is premature optimization. And premature optimization is highly expensive. And it also needs to take into account the thing called Hofstadter's law, right? Because if you are adding all this complexity, it gets complexer. And once you think you've almost tackled the complexity, oh, wait, there's something else coming out of the big head, and oh, what, shit, we need to take even. This is Hofstadter's law, right? It always takes longer than you think, even if you take into account Hofstadter's law. Like, I was working with a small mobile team recently, and they were building a new mobile app. So what's the first thing you need to do, right? Well, let's log in, right? Okay, so we'll put 2 text boxes on the screen and a button. And we fill something, we click it. That's the first thing you can do, right? And then I said, so what's next? I thought, well, probably they connect it to an API or something. And I said, no, we need a Redux store. A what? A Redux store. Why do you need a Redux store? To send a username and a password to an API. Well, we always do a Redux store. Now, those arguments are so wrong, and these arguments are costing us tons and tons of time and money, and now I don't know where my presenter is. Where do I put it? What? Oh, wait, there's more. There's a secret thing here, right? So the problem is, big trick, well done. So the problem is you can only spend your time once. This goes for everything in life, by the way. I learned to do this by getting a burnout, seriously, in 2009, 2010, and it doesn't help, right? You can only spend your time once. Realize that for sure, right? So the things you need to do is you need to solve the right challenges. If you do not have a scalability challenge, don't solve it. Right? I started building microservices in 2014 with an insurance company. The first thing we built was an account service. And we deployed it. It was a Java service, and we deployed it somewhere, a local machine, somewhere on a Unix. We couldn't have Unix in the office because it was all Microsoft stuff. And so we put it under somebody's desk, and we ran it against the box 86,000 times per minute. I'm like, what? We solved the scalability problem. And we didn't spend any effort at it at all. We never had to do something with scalability. So the question that you need to ask yourself all the time, every day, every time somebody comes up with a stupid suggestion or a very smart suggestion, the question is, do we really need this now? All the teams I work with, they know this question. They ask these questions every day. Especially when I say something like, you know what, I'll build in, and then they said, do we need this now? And the question is, do you really need this now? No, you don't. And if you don't do it. It's as simple as that, right? That's the simplest thing you can do. And simplicity rules, because code is not a product, right? It's not like the more code we write, the more we produce. Actually, code is cost. Because every line of code we write takes time, it takes money, it needs to be maintained, somebody needs to deploy it, somebody needs to test it. So it's expensive. So every line of code that you don't have to write, you shouldn't. And then the intuition part comes back. It's like, okay, I look at this piece of code, this is a jest test, and I look at it and I'm like, this is actually code I picked up like 2 weeks ago. It's my own code, actually. And, and I look at it and I'm like, yeah, it's okay-ish, I guess. It's like 5 lines per function. I don't like 5 lines per function. Let's make it 3. So I refactored it. It took me about half an hour. And I was like, okay, I created this add_id function, which sort of does the same trick as the other 3 lines, and I make it simpler. And it's now simpler to maintain, meaning it's cheaper, right? And the cheaper the code is, the better it is, because the best code and the easiest code to maintain is no code. By the way, that doesn't mean I'm in favor of stuff like low code and stuff. We can have discussions about that, but it means that the code you don't write, you don't have to maintain. That is pretty much important, right? And I realized that over time, when I got over this bump, and I went down to the other side to where the simple code lives, I started realizing that most of the functions I write are single-line functions. And a bit like this, right? These are single-line functions. They're lambdas, basically, but and this is all they do. You can hardly go wrong with code like this, right? So you're thinking, yeah, but I could never do this. It doesn't have to be, but you have to think about getting over the hill. And where that hill is for you is different than it is for me, probably, right? So, and then I also realized that I started doing these little things that when I first started doing it, I didn't realize it, but I got sort of conscious about doing this. I start every function I write with return. It's the first word I write in a function. It's not the last word I write in a function. I can write like lines of code and then, oh, return this, right? No, I took it the other way around and said, okay, return. What do I need to return? Well, maybe a Boolean, maybe an object, maybe this, whatever. Could be anything, right? And I started writing it back to front. So to reverse the order in how I write my code, I changed it to, okay, I need to return it. What do I need to do to return this? Oh, I probably need to get it from a database. Oh, that means I have to talk to the gateway. I probably need to do some validation maybe, or stuff like that, right? So you start thinking about it. It helps you reason about the way you write your code. And this is a technique that works really, really well for me. I'm trying to teach that to the teams I work with as well. Not that I say it's mandatory, it's an idea, right? And it's with naming things as well. We are very used to, especially in the Java world, to name the variables we have, the parameters we have, and give them the same name as the class. Do we still do this in Java? Or? Yeah, right. Why do we do this? What's the point? I realized that when we had Notepad that we need to program in, that it would be useful to give the variable the same name as the class name because, well, if I use it 10,000 lines down the road, I don't know what it is anymore. But these days, we have all really good UIs, right? Or for IDEs, we have WebStorm, we have IntelliJ, VS Code, whatever you use these days. But they know this, right? I can hover over it and they say, well, it's an order repository. So I don't have to name it the order repository. I can name it in a way that it makes sense to the rest of the code. I'll give you an example here. It says, return this orders by order item, which is much more logical, much more readable than saying, oh, return this.order repository.get by whatever, right? It doesn't matter where it comes from, it matters how it reads. And that's a different way of looking at it, right? Especially if you have classes like this. If you would make a function, put this in a parameter, and give it the same name, it's already way beyond the maximum length of the line, right? So it doesn't have to be. I'm not saying this is badly named. It's probably very accurately named, but I'm saying is if you make a parameter of this type, just name it A. Or SI for servlet initializer, right? Good enough, because it works, especially if you write the small functions. Because in a small function, it's always there in front of your head, which is good, right? Or for instance, if I look at parameters, I name them really short. Sometimes, usually just one character. And I know this is almost forbidden, right? And this is exactly what I was talking about a Scrum community getting stuck in shoe. It means, why wouldn't you name a variable with one character? If it's clear enough, it's only used in the next line. So why would I care if it's called Sounds nice, right? Also, the most secure code is no code, right? So, next topic. We have to talk a little bit about architecture, right? And the thing about architecture is, I started to realize a long time ago that my architectures need to be able to adapt. I need to be able to move to different databases, new technology, or different patterns, or adding all sorts of new stuff to it without it breaking. Now, since I started writing microservices in 2014, I don't have a single repo anymore. I have like tons of repos. And the problem with that is, if you all let them grow into their own architecture, they become impossible to read, right? And because these things last for a long time, you need to be able to understand them. So now I've thought back about that, and like the great Java programmer Charles Darwin, he said, well, he has a beard, right? So it's not the strongest of the architectures that survives, nor the most complex that survives. It's the one that is the most adaptable to change, right? And Neil Ford, of course, who doesn't have a beard, he says, well, in his new book about evolutionary architecture, he says, well, evolutionary architecture supports continual and incremental change as a first principle among multiple dimensions. That's a bit of a tough sentence, and let Neil explain that, but basically, a microservices architecture really fits this, because you can change it in different dimensions. And then I thought back about a book I once wrote, and a lot of people in the room, oh, is this the dude that wrote the unreadable book about UML? Yes, that's me too. And sorry, I'll try to write better readable books. And in that book actually is an architecture. And that an architectural pattern actually. And that architectural pattern is one that I've been dragging along for almost 25 years now, and it's still there. And it's been implemented in very different languages and very different platforms and ecosystems. It's really simple. It has entities, well, it's DDD, right, in its heart, repositories around it. It has use cases in a sort of process layer. They're really useful, actually, from the UML book, of course. And this is how you talk to it. This is your interface towards it. These are your resource classes. And you know what? You need to get out to get the data from other services, from elsewhere, from a database, whatever database, wherever it is. And this is the architecture, right? And the nice thing is, recently, I went into Bitbucket. Sort of archaeological, you don't go voluntarily into Bitbucket, right? But and I discovered a code base of my own team from 2010, I think it was. It has the same things, right? It has like a data layer, and it has a business layer, and it has a process layer, and it has a web layer. And I went into it, and it looks exactly the same as I would write my code right now, except that the way I write it has progressed, right? So here's a repository class from that code base, basically, written in C#. And you can see it's C# because the brackets are on the wrong lines. And it's only because I do JavaScript, huh? It's like, no, just kidding. I had a recruiter recently in the company said, yeah, I have a CV for you. And he said, what? And he said, well, yeah, it's a Java program. I said, well, we're doing JavaScript. And I said, well, that's the same, right? Anyway, so much for recruiting. So anyway, this is one from C# in 2008 or 2010. I don't remember anymore. This is one in Java. This comes from a code base that we wrote in 2015. It's still a repository. It's still the same pattern. It does the same thing, except that this is highly organized around using a try class, which I'll get to next. And this is one, Java. Yeah, this is Java. Okay. Oh yeah, use ligatures. So anyway, it doesn't matter. So, and this is one in TypeScript. This is very recent, but it's the same pattern, right? So I've been dragging this pattern along for a very long time, and it still works. Yeah, you see the TypeScript one, right? So, and I shortened the code, right? It's now repo. It's a large improvement from repository. So the whole thing about architecture is this thing. So this is me, my girlfriend, my son, and his girlfriend in Rome. And because we're in Rome because we decided to go to Thailand. Well, given COVID, you can decide all you want to go to Thailand, but it didn't work, right? And then we thought, we'll go to Iceland, because it's so cold, there's no COVID. But apparently more people thought about it, so car rental for a week was 4,000 euros. And then we decided not to go to Iceland. And then we figured about, maybe Norway or Turkey, and both of the countries, just 2 weeks before we wanted to go on holiday, collapsed. And then we said, well, let's go to Italy. Italy's safe, right? Italy's always safe. Well, sort of, but it's nice. And we decided the last day to go to Italy. And what the point in this is that if I would have made the decision to go to Thailand, booked the tickets, and we got the refusal to go there, we'd be stuck. So we waited until the last responsible moment to make the decision. And this is exactly what you need to do with architectural decisions. You need to wait until the very last moment in time that you can make that decision. And you need to figure out for yourselves when that moment is. It's not necessarily the last day because you still need to build it or implement it. But wait for it as long as you can. Right? So, what's the next step? Well, the next step is to realize that this world is complex. At worst, it's chaotic. And I'll explain to you what that is. So, I'll give you a nice example. This is the 32 best React state management libraries. Are you like, 32 React state management libraries? What do you mean? And like, there are 32 React state management libraries? Well, given that these are just the best, and you have to choose from it, right? Of course, everybody chooses Redux and the rest of it. I have no idea what they do. So, here's the point. This is the Cynefin framework. You know this one, right? The Cynefin framework, I'll explain really briefly, is a very interesting model that says in the obvious zone, if you live in that, you have a best practice. You apply that best practice, done. Simple, right? And then there's the complicated zone. In the complicated zone, there might be a good practice, but you still need to figure out which one. So it's probably one of those 32 React state management libraries. You don't know which one, you need to figure it out. Once you figure it out, you can get going. The problem is that most of us live in complex zones or in chaotic zones. Now, in complex zones, that means there is no best practice yet. We don't know yet. It's coming. It's sort of progressing. Out there in the world, people are doing this too. They see the same problems. We sort of find the same sort of solutions. We can work together on it. We have an emergent practice. In the chaotic zone, it's even worse. There are no practices because nobody's done this before. We don't know how to do this. If you make a choice to go for a technology that lives in the chaotic context, well, you're basically up for trouble, right? That's not necessarily wrong, by the way, but it is a fact. So here's the thing. There are no best practices. In what we do, because we live in the complex and the chaotic zones, there are no best practices. There's no such thing that's valid everywhere. Even when it's valid in the whole Java community, or even the whole Java and the .NET community, it might not be valid in the Python community or in the JavaScript community because they do different things, right? So there is no such thing as a best practice. Well, there are good practices, of course. There's things that you can count on because you need things that you can count on, like stuff like coupling and cohesion, right? You're always going for low coupling and high cohesion. That's what you do. Also, the Unix philosophy is one really nicely, right? It says, well, write programs that do one thing well. None of us do that, by the way. We write way too big programs, right? That's good. And then you think, yes, now comes the solid part. Oh, okay. Solid is okay, right? So the single responsibility principle, I live by this, basically, because I write one lines of code. They can only have one goal. There cannot be more goals in a single line of code. Well, depend on how you construct it. So if I look at the bit of code like this, which is from my own team, I look at it like, what? You have like 5 gateways to fill one repo? What are you doing? And then I look at the code, and I'm like, okay, it's asynchronous, I get that. It's using the right structure. I still can't read it. Intuitively, I don't like this code. I think I need to refactor this. It's Boy Scout rule, right? You need to improve on it once you see it. So I was in trouble, but I did actually. So, and the open close principle, yes, always, right? But some other stuff, like the DI stuff, well, I did DI and I promoted DI and I built DI engines and I built frameworks for it and I used it everywhere, including in Java, right? This is my own code basically from a previous client. See, here's some injection and, well, we're creating instances of contract repository, which of course is called contract repository. And the organization repository is called organization repository. See, this is what I mean. It could have well be called contracts, right? Would be much readabler. But this is where we do it. And it's okay, it works. But when I started writing the easy framework, the open source framework, I was like, I don't need it yet, right? I don't need the DI yet. So I'm going to leave it out as long as I can. And it's still not in there. And we're writing full-blown commercial applications with it, it's still not in there. Apparently, we didn't find a need for it. So you can perfectly write code without doing dependency injection. Now that's news, right? So this is how it looks like. So the only thing I do is, well, if I need a new instance of the managed shop use case class, I'll just create it. This is a default parameter. And if I, in my test, need to fill it with something else, I'll just put it in there, right? That's it. So, one step up. This is my favorite part. Some of you like monads, some of you don't. The latter group is probably the majority. But let me tell you, you need them. So, there's an interesting quote from Douglas Crockford, who, although he has a beard, doesn't do Java. He says, well, monads are amazing. They are simple things, almost trivially implemented, with enormous power to manage complexity. He also says, but understanding them is surprisingly difficult. It is. And most people, once they have that aha moment, seem to lose the ability to explain them to others. So if you think it's smart for me to try to explain it to you, it's not. So I'm not going to explain it to you, because you all know this thing, right? Do you like it? The optional? No, it's still not there, right? So, what it does, basically, it takes away side effects. That is what all monads do for you. They take away side effects. So you can execute functions on something and taking away the side effects. I'll show you another example. The other example is here, right? This is, if you look at the second function, I'll try to sort of enlarge this a bit or enlighten it. This is an update function. It says this gateway by ID, and then it says then. Now then is a method on a monad called promise, which handles, as the side effect, handles asynchronous behavior. So basically waits for the previous one to get back from wherever it's coming from, and then takes the next step. And if one of those steps fails, it gets into a catch clause. And then it sort of throws, and it throws up and up and up and up. And this is really convenient. There's another monad in here. It's a really tiny one. You don't see it at first. It says, when J not as defined, reject. This is a very small monad that I built into the Easy framework that does validation on stuff. It's all. It's just about readability in this case. And it knows how to validate. So you don't have to remember how to validate that stuff. Right? So that's the point. And the nice thing is that as soon as you start looking at monads, is what they do, and I'll put a nice graphic example of it on the slide next, saying, well, all of these functions that are in there, they're basically lambdas. Each of these lambdas is, or can be, well, either a pure function, meaning it has no side effects because it just does that, or it's a really simple function, usually a one-liner, that I can test separately. So it makes testing a lot easier. So here's how monads work. And I'll try to explain it anyway, despite Douglas Crockford. So a monad is basically a box. The thing that you want to do something with, you put it inside of the box, right? Once it's inside of the box, you can send functions to it, to the box, right? And the box will handle that function on the thing that's inside of the box. It usually does a transformation of it into a different type, a different color, whatever it could be, right? While doing that, it takes away the side effect of doing that. You can do as many of these things as you like. They're usually called like map, flat map, reduce, stuff like that. Basically, an array is also sort of like a monad. And then eventually, you take the result out of the box. Now, all of the handling of these individual steps in between have been done by your monad, and they have been done in a safe way. I'll show you an example. So this is a choose class. Basically, well, there's basically two classes. There's a choose, or case, which is here, and there's a found, which inherits from case. And they're highly generic, and the only thing it does, it says, well, give me a predicate for every case, and a function that you need to execute, dankjewel, and a function that you need to execute in case of the predicate is true. So here's a try-catch block. An actual try-catch block, by the way, once I saw this and I put it on my slide, I replaced it by another monad called a try. And if you use this kind of stuff, it looks like this. It's saying, right, given the predicate is auth error, I need you to do this. If it is an exception does not exist, then you need to do this. If it is, et cetera, et cetera, et cetera. If it's a response, you do this, and you create the following thing that comes out. And if all fails, it's basically saying, OK, you need to return this, what's underneath here. Now, what this does is all of these functions, the predicates and the functions that you execute, they could go wrong, right? And when they go wrong, they break your code. So it's the case statement that handles that takes it away. You could, by the way, build this in Java in probably less than an hour, right? And it's extremely useful. It becomes really, really powerful stuff. So think about monads for a bit. And this is monads, when they were introduced into my life, I was in a Java project in 2014, 15. And a guy on my team came up with them. And I was like, what is this stuff, right? And we had a big team, and I was the CTO. We had like 40 people, and it was adopted by sort of half of the people and not adopted by the other half of the people. Both is okay, but the monadic code is far more robust and actually far more readable, I think, than the non-robust code. It's like for if, for if, for if. Code like that, right? You lose that kind of code. Basically, if you look into the easy framework itself, there's very little if statements in the whole framework, because they've all been, well, monadized, et cetera, et cetera. So, a few more points that I need to make. Well, crap, what I'm doing now. Pressing the wrong button. You don't see that, by the way. How do I get rid of that? So, my slide deck doesn't want to go in the same direction I want to go in. Okay, there goes your touchscreen. It's stuck. Let's you get with this Microsoft. No, what's it called? Wow, it's sort of back. Now I'm hoping that is. So we're talking about stuff that is complex, right? And stuff that is chaotic. Now, if this is your tech stack, you think I made this up, right? I didn't. This is the actual tech stack of a company I worked for. A couple of people in the room here worked for it too. So I made all the developers come up with a list of all the tech that we were using. This is it. There were 30 developers. You can never do this, right? This is just terrible. And that's what Edgar Dijkstra says. He says, well, basically, a programmer has to be able to think in terms of conceptual hierarchies that are much deeper than a single mind ever needed to face before. You get to the point that you realize that most of the stuff out there, I have no idea how it works. I've been writing code for 40 years. I still don't know everything. And it gets worse. I know little and little and little. Because the amount of stuff that you need to know to build software, it grows and it grows and it grows and it grows. And there's no point anymore in thinking that you can know it all. I used to know it all when I was writing Pascal on my little computer in my student room. That was my universe, right? But the universe is a lot bigger these days. And for you have to remember that you are on the left side of this diagram, meaning this. Meaning, this is Dave Snowden, the author of the Cynefin framework. He says, well, basically, in a chaotic context, searching for the right answers is pointless. You cannot. However, if you are in the chaotic domain, this is the best place to start innovating. And you know how you innovate? You take really small steps. You set a dot at the horizon, you take really small steps, and you start doing experiments. I'll show you what an experiment is. It's a test done in order to learn something or to discover if something works or is true. Cool, right? So you do an experiment. If it fails, well, turn again. If it succeeds, continue. That's the only way we get through this stuff. And you learn by doing. Now, the problem of these, all these things that you need to know to build software, that it's too much, best comes down to looking at a collective. This is the Newcomer collective, it's a Dutch big band, and they play in all sorts of different subsets of what they're doing here, right? And they all can play their own instrument really well. They cannot play each other's instruments usually, or sometimes they can a little bit, and it's a bit like how we work in tech, right? What I see is that beyond Scrum and beyond Agile, how we defined it 20 years ago, we go into larger groups of people, because only larger groups of people have the total amount of knowledge that you need to know to build decent software. You need to little know about front end, about testing in the front end, about AWS, about the Google Cloud, about Java, about Kotlin, about writing microservices, about DDD, about TDD, about everything, right? And you cannot know it all anymore. That means all the work that we do is not individual work. We're always part of a team. This is basically what I try to teach my own team, is work as a team, right? Took me about a year, and they're now completely collaborating as a team. The nice thing is that each individual item that you need to work on, each story or whatever you call it, usually can be handled by a subset of this, right? A subset of the total set of skills that you have on your total team. Well, maybe you need a front-ender or an architect. I know René doesn't like it if I put front-end next to his name, but... So the question then comes back to, again, making it smaller. And the question is, what small problem are we solving today? And if this is your only cycle in the process, you can get rid of the sprints and the retrospectives and the sprint planning meetings and the estimation thingies and the story points and whatever. You can get rid of all of it, and it really works. You can go to say, okay, this is what I do. I pick an item from the board. I'm like, this is what I want to do. Who's coming to help? And you look around the team and people say, that sounds interesting. I want to know more about this. Or I do know more about this, and I'll help you. And it could be like, whatever, configuring the load balancer with some new stuff, or it could be building a single service, it could be building some front ends, it could be anything, right? You just do this. You get together, you form a band, you discuss the work that you need to do, you just do it. You go through, of course, it requires really full, complete, continuous delivery. You do the work, you go, you do the spend, and you do the same thing the next day. And the nice thing is, this model fits into most of the teams that I work with so far. And it helps you to spread the knowledge. Like, this is a developer and an ops guy. These are two developers and a QA guy. Of course, the QA guy is a stand. This is two Java developers, for instance. This is an architect and a developer. You can see it's an architect. He's praying for it to work. And this is a nice technique that I've sort of, well, let's say invented over the last 6-7 years and worked with it, and it really works really well because leadership becomes contextual. It's just that team. Where they work, when they work, whether that's from 10 in the evening till 3 in the morning, I couldn't care less. I actually say that to my team, guys. Guys, if you have to take care of your kids in the morning, do it at night. I don't care, as long as you do the work that you think you can do, right? It broadens your skill sets really, really fast, by the way. You don't need sprints anymore. You don't need estimates. Refinements, they're gone because you only do this in this really small group of 2-3 people working on this item instead of with this whole group of people who don't care shit about what you're doing. And you can work anytime you want, anywhere, right? And I recently got into a discussion about, does this stuff scale? And I'm like, I only work with small teams and small companies, so I don't know. So Marcin from ING, Marcin, are you in the room, Marcin, somewhere? Hello. He said, you're wrong. It really scales really, really well. So thank you for that. It really made my day, actually. So the last question that I want to ask you is, why did we never go to Italy? This is my mom. She's 82. My dad died 2 years ago. And for the majority of their life, they went to the same campsite for like 25, maybe 30 years. And they enjoy that. They go to the same spot on the campsite. They know the people at reception. They say, hi, good to have you back. They go to the same bars, the same restaurants. They're recognized. They like that, right? And that's really good. But when I got back from holiday from Italy, she looked at the picture and said, why didn't we never go to Italy? And I'm like, well, because you always go to the same place in France for 25 years. Yeah, she said. And that was good. So the point here is that some people do like change. That's good. Some people do not like change. That's also good, right? To build software, we need both. Or maybe there's multiple types of people. Maybe there's people that say, I only do green. I don't know. But there's different types of people, and you need all of these people on board. You cannot say, you would not want to do a project with 5 people like me. That would never succeed, right? You would build beautiful software, but it wouldn't work. And we would never finish it. I need complete finishers on my team, right? I need people who picked it up. I have a guy on my team, I call him the bezemwagen. He's great. He's amazing, actually. So you need that. But the thing is, if you do want that change, if you do want to break through, if you do want to look into, let's say, monads, or just naming things by one character instead of like, swoop, do it. Because if you want that change, there's only one person in the room who can ignite that change. I tried this once, by the way, at the local football club, and get like all these parents coming in, and I was like, I parked it the wrong way, see what happens. They all started parking it the wrong way. It really works, actually. But if you want to make sure, if you, in this room, want to make a change, you want to change them, you want to make it better, grow beyond the big mountain and go into more simpler code, whatever that can be for you, there's only one person to ignite that, and that is you, right? So never, ever in your life, be afraid to ask the newcomer questions. Like, what does this button do? What is a template method? All the things that you are supposed to know, if you don't know them, ask, right? Doesn't matter if people think you're stupid, you're not, because you dare to ask, that is important. And then you take really small steps. And you never, ever, ever stop learning. And the most important thing is, you never forget to have fun. Well, and if all else fails, you can always remove the node modules and do an npm install. One last thing, and this is maybe the most important thing in the whole talk, is take your mother out for dinner more often. Okay, thank you all for having me. I hope you have a nice rest of the day.